Hello students. Now we are actually studying the second section or next part of our unit 2, that is requirement analysis and engineering. And this second section of requirement analysis and engineering focuses on diagrams. So we have already seen, as per the SDLC, software development lifecycle, starting from communication and reaching to the last step, that is deployment. In between, somewhere we'll come across requirement engineering step, that is requirement collection and then requirement analysis. So it is collection, gathering, integration, analysis. All these steps will be carried out in requirement analysis or engineering, which we have already seen in our earlier videos. So apart from those requirement collection, gathering, analysis, something we need to apply on these requirements. These requirements will be given as input to the next section, that is design. And there itself designing or consists of, or you can say modeling phase consists of drawing n number of different UML diagrams, or starting from flowchart, entity relationship diagram, then you can say block diagram or your data flow diagram, and then coming to UML diagrams, that is unified modeling language. So these UML diagrams we are drawing under modeling and then we are analyzing them. That means obviously these UML diagrams will have some kind of documentation with them. So both together is going to give me a roadway that how your system is going to behave or how your system data flow will be carried out for the successful implementation or successful execution of the system. So this is the next step after requirement analysis and collection. So we have covered this requirement engineering 3 videos. That means complete introduction part of requirement engineering, gathering, collection, all steps under requirement engineering. Now the next section of requirement engineering is UML diagram. So we can see, as it is UML diagram, that is unified modeling language. Obviously it is some kind of a common platform where all these diagrams and modeling can be done easily. So all the icons, whatever tools we are going to use, whatever symbols we are going to use, will be universally accepted and they are going to be applied for your problem domain. So coming to UML 2.0 version, we are going to study total 13 UML diagrams, and these 13 UML diagrams are obviously given through UML 2.0 version. So these 13 diagrams we need to study. Actually all these 13 diagrams are not there in your syllabus, but we will cover it because in next year for your BE project you will be requiring any of the diagram as per the requirement from the authorities. So now coming to that UML diagram portion, now this is a very important part because in your mini project video also, that not video, mini project review presentation also, the last point was use case scenarios. That means there you have to explain the use case scenario of your system, of your project, and you have to draw use case diagram. That is the very first diagram in UML 13 diagrams list. So what is that use case and use case diagram, how it will be drawn, different scenarios of use case diagram, each and every detailing we are going to study in this presentation video and next presentation video also. Fine. Coming back to the topic, a diagram, as you all know, it is a graphical representation or structure, okay, of a set of elements. Obviously these all elements are connected to each other because they are going to share some kind of relationship, because some kind of data flow, data transfer, message flow is going to occur through these relationships. So some elements are connected to each other, that is a graphical representation, and through these connections or interconnections you can say, or links you can say, or associations you can say, they are going to share some relationships, or they are going to exhibit some kind of functionality or property. Fine. Each diagram is supported by a technical documentation. So why these two keywords are highlighted in blue font? Because diagram only is not going to suffice the problem statement or domain. Along with that diagram, if we are going to have a good documentation also, then it is a kind of good explanation or specification or elaboration for that particular diagram. Only diagram is not going to be explained here. That is not going to give me the complete understanding or meaning of the system. Some kind of documentation is required when you are talking about some diagram specification. Okay, so it is going to specify the diagram in more detail. So a diagram without documentation is of little value. Moving ahead, actor and use case. Now here actually I am going to start with use case diagram. So in use case diagram, just remember, if you still remember, one small diagram we have seen as an example point of view for use case diagram, where this thin person acts as an actor. It is an actor. Now this actor is a user of a system. That means this particular user is going to play some role. Now not necessarily this should be a living entity. Okay, it can be a human or it can be an external system. It can be a simple entity. So this is just a representation of the user of your system. Now when we are going to draw this particular actor, there are two types to be drawn. Okay, one is primary actor, another one is secondary actor. So we are going to see this in our further slide. That time I'll explain you which actors are called as primary and which are as secondary. Fine, so just understand this thin person is called as an actor, which is going to play some particular role, and it can be a human, or it can be a system, or it can be an entity. Now this ellipse, borrow book, it is a use case because it is going to define you some task which actor needs to perform with the help of the system. That means actor is going to borrow a book from the system. Maybe the system name is library management system. Okay, so whoever is the actor is a student or the faculty or the user of a system who needs to borrow the book from that library. Fine. So this particular book, borrow book, is a use case. That means it is a functionality of the system. So always remember why we are drawing use case diagram as a very first UML diagram for any of the projects, say it is mini project or a BE project, because use case diagram always focuses on functionalities of your system. That's why functionalities of the system should be very well known at first step only. What functionalities my system is going to offer, and then only you can decide if these are the functionalities offered by my system, how I'm going to develop those functionalities, develop those services. So that kind of implementation or technical thing will click in your mind. But before that, you should be knowing that what are the different functionalities offered by your system. The way you are drawing ER diagrams in DBMS, say there also you are going to decide how many entities or entity systems you are going to use in your diagram or system, because obviously they are going to offer me some service. That's why you are including all those entities in your system. Same way, borrow book is a use case functionality. So this ellipse where borrow book is written, this ellipse is called as use case, and this is a functionality or service of the system. So use cases are of different scenarios because they are representing the concept of viewpoint analysis. So n number of use case diagrams you can draw for one system only. Let's say take example of library management system. Now looking at library management system, maybe my perspective or viewpoint is different than yours. So my use case diagram will be different from yours. So always remember, a use case diagram gives functionality or services offered by the system, but it works upon the viewpoint analysis of the user. Okay, so different users, different viewpoints, and different handling of systems. So different use case diagrams will be there for one problem statement. Now going ahead, each and every explanation or detailing is given here. A scenario is an instance of a use case. Actor is a role, not an individual. Librarian can have many roles. Actor must be a beneficiary, okay, of the use case. Fine. That means example, not librarian who processes book when borrowed. And in UML, system boundary is a set of use cases. So we are going to see a system boundary that is a vertical rectangle, and within that system boundary we are going to draw n number of use cases. Sometimes they are connected to each other, sometimes they are not. They only show the functionalities of the system or services offered by the system in a flow, one after another. So it shows you which particular service or functionality will be offered after what. So that flow, that hierarchy need to be maintained inside that system boundary. So system boundary is a collection of, okay, all use cases. That means set of use cases. So scenario means we have to work on different situations. Once again, I'll give you the same example. If I'm going to visit an ATM machine, obviously successful scenario will be everything is working very fine and smoothly, and I am able to withdraw the money with receipt. But suppose you are considering different failure cases here. For example, sometimes money is not withdrawn, sometimes receipt is not acquired, sometimes PIN number is not working, sometimes card is rejected. So that problem is there in that card slot. So n number of failure cases are possible with that same ATM machine. All these failure cases are different scenarios of the same product. So you have to work on different scenarios, successful also and failure also. So now a scenario is a tool used during requirement analysis to walk through a specific interaction with a proposed system. Example can be, the requirements are being developed for a system that will enable university students to take quizzes online from their own rooms using a web browser. Okay, so we'll create a scenario for a typical student if they want to appear for quiz or take quiz online from their specific rooms, particular rooms using a web browser. So what they are doing here, see the individual, Philip Glass, senior at Cornell, major in computer science, location Risley Hall. What is the equipment here? Dell laptop attached to the Cornell dormitory network, Mozilla 5.1 browser and sidecar, whatever, for installation, whatever is required. So this is the equipment used here, okay, for that connection, and he is a particular individual who is working as an actor here. Fine. Now what is the scenario? That PG powers up computer, and who is PG now here? Philip Glass, okay, the person, actor. They are just giving you the viewpoint analysis, the scenario of that Philip, okay, of that person Philip for this online quiz scenario. So Philip powers up computer and authenticates using sidecar. Philip starts browser and types URL of quiz system because it is online, and quiz system displays list of options. Okay. Now Philip selects CS501 quiz 1. A list of questions is displayed there, each marked to indicate whether completed or not. Now Philip selects a question and specifies whether he will submit a new answer or edit a previous answer. For the first question, he is submitting a new answer. He has a choice whether to type the solution into the browser or to attach a separate file. He decides to attach a file. So this is a complete flow they have explained for conducting an online quiz, step by step, one after another. All these steps will be represented in ellipses inside system or subject boundary when you're talking about use case diagram. So first of all, you should know what are the different functionalities or services offered by the system. So 8th point is for the second question, he is editing a previous answer. He chooses to delete a solution previously typed into the browser and to replace it with an attached file. So now Philip has completed the quiz. He selects an option that submits the quiz to the grading system. Philip now wishes to change the solution. System does not permit because he has already submitted it, right? And now Philip logs off. So now this is the complete online quiz scenario for one particular individual with their viewpoint. So a scenario is useful in discussing a proposed system with a client but needs to be generalized as part of requirement modeling. A use case provides such a model. Now you can see this is the quiz taker, actor here, and who is going to take quiz, check grades and request regrade. So these are the different association links. Now these are just association link. I will not call them unidirectional association because there is no arrow here. Okay, with this association you can see actor is interacting with the system, and obviously system is also associated with the actor because there is no arrow. So you cannot show here whether it is unidirectional or bidirectional. So it's a simple association link. Now instructor is another role played here, actor, who is going to set quiz, grade and regrade. So actor is a role, okay. An individual can be a quiz taker on one occasion and an instructor at the another one. So you have to just define different roles. Now you can say, see, the quiz taker take quiz and check grades, okay. That is authenticate. That means take quiz and check grades include, that is the mandatory part, must part, compulsory part, authentication. So obviously remember, whenever take quiz or check grades, their compulsory part is authenticate, but include, this arrow goes out of the take quiz ellipse. It is not going inside because still it is include. So don't get confused. Many students get confused in these relationships of use cases. These two relationships are include and extend. Okay, so this is the one include relationship where it is a dotted line. Yes, this is one dependency relationship which is include. Okay, and obviously this include dependency relationship is written into these two less than sign and two greater than sign. These are called as stereotypes. So include is the one relationship in use case diagram, another one is extend. So in this slide, just understand what is include. This take quiz, one ellipse or use case and another one check grades. They need the mandatory part to take quiz and check grade, that is authentication of that quiz taker. So authentication is a compulsory part of these two, take quiz and check grades. Fine. So when it is a compulsory part, that times the dependency arrow, that means this include relationship will go out of that ellipse, that is take quiz, fine, and check grades. So understand, includes will always go out of the ellipse, okay. Includes will always go out of the ellipse and includes will always focus on the compulsory mandatory part of the use case. Similarly, when we will talk about the another relationship in use case diagram, that is extend. So same way extend is also written inside stereotype with the same dotted arrow, that is dependency relationship, but now take quiz consists of some optional kind of relationship, that is connection fails. Connection fails is not obviously always going to happen. No, sometimes or maybe sometimes this connection failure error will come. That is optional thing, maybe, okay, may or may not. It is not mandatory or compulsory part. That's why it is extend. But now this dotted dependency relationship ka arrow will come inside take quiz. So always remember, whenever for take quiz kind of one ellipse or one use case you want to show something as mandatory part, include, arrow will go out of the take quiz. When you want to show some kind of optional, may or may not be kind of relationship with some use case, that is take quiz example here, then arrow will come inside take quiz use case. So understand the meaning. Include is used for events that are in flow of events of the source use case. These are the mandatory part, but extend, it is used for exceptional conditions. Okay, especially those can occur at any time. Connection fail can occur at any time, but not mandatory that it will be there at all time. So may or may not be, it is optional, exceptional kind of thing. Extend. Fine. Going ahead, use cases in development cycle. So as I've told you, it is going to work on functionalities of the system, and it is a very first diagram in UML diagram. Now documentation, reasons for documentation, why they are required, because documentation gives you good visibility, planning, complete budget requirement, infrastructure requirement, entire report. User support, that is user manual, how to use that particular software or system. Team communication, what are the different you can say the team members involved here and their detailing. Maintenance and evolution, so all the configuration management, hardware, software, tools, all requirements will come here. So documentation is going to give me all the kind of reading material which is not available in diagrams. Diagram is only going to give me the picture or structure of the system, the flow of system. Characteristics of documentation, it should be accurate, kept current, all the recent updates should be there in that documentation. Appropriate for audience, whoever is going to read that documentation, it should be easily understood by them. Maintained online, okay, so that all can access it. Digital copy must be there. Simple but professional in style and appearance, because even though you are going to do many aesthetics, you are going to apply very look and appearance good for that documentation, but if it is not understood by the content and content is not good, not of good quality, it is of no use. Okay, so documentation is expensive, quality, not volume wise. Fine. So going ahead, requirement specification, purpose. So all these things we have already covered, but still, document that describes the requirements to stakeholders in a precise manner, expressed in terms that stakeholders can understand, precise and specific and crisp, comprehensible from many viewpoints, reviewed by stakeholders, those who are going to use the system and again and again, they should review it number of times, whether it is properly drafted or not, and must be clear about assumptions and no confusions or no ambiguities in that particular documentation. It describes the requirements to the implementers, precise, specific as possible. These things we have already covered. Okay, because if documentation is good, diagrams are correctly given, then it is easy for the developers to implement the system based on that documentation. It records the requirements for the future, because documentation is one kind of record keeping, logging of the detailing of the system. Fine. So digital copy, even if we are not having hard copy or if it is misplaced, digital copy is always going to be there with you, maybe on cloud or other storage media. It may be contractual document, yes. So it is a kind of you can see mutual agreement that where the documentation will be kept, like an MOU with the company. Now requirements must be specific. For example, they have taken for university admission system. Now it will be request for information received by email must be answered within 1 business day. So these are the requirements if you are working on your project. Some requirements or assumptions you have to specify there in the documentation. That means 1 business day is enough for some kind of reply response. An admission officer who is talking to an applicant by telephone must be able to receive the applicant's records within 10 seconds. So everywhere you can see some measures are given, some time limit is given, some figure is there, something is tangible here. No financial aid offer may exceed the maximum defined in section 8.7. So this is their section. All these things need to be very crisp and precisely explained in your documentation with the restrictions. Fine. Now documentation of use case, name is take quiz, actor is quiz taker. Now what are the flow of events? Just now we have seen in our earlier slide how the online quiz conduction takes place. Fine. So these are the different steps connecting to the quiz server. Then authentication is checked. Then it selects a quiz from list of options, selects question and edits the solution. Then quiz taker either submits a completed quiz or saves the current state. And if it is submitted, even if he wants to change the solution, he cannot change it. Okay, it is going to notify to the grading system. Now quiz taker or saves current state and notifies quiz taker of incomplete submission, logs out, Entry condition, quiz taker must have Cornell net ID because that particular institute it is or university it is, and computing requirements will be whatever hardware software is required there. Now client must understand the requirements properly. Specification. Do not assume that anybody has read a document. Do not assume that anybody understands document. You have to clearly specify the detailing and elaboration part, that whenever the user is going to read the document, they have to understand what the system is about. Go through the requirement specification with the client line by line. It is usual for the client and developer to sign the requirement document when it is agreed. It is some kind of mutual bonding or agreement in between two parties. It's a kind of deal. So if all the drafts and points are clearly convinced by both the parties, then only that document will be signed here. Sorry. Okay. And now this is the last slide, that is requirement analysis versus system design. So requirements analysis should make minimal assumptions about system design, but requirement definition must be consistent. It should be clear and it should be very specific with computing technology and resources available. So obviously do not allow the requirement analysis to prejudge the system design, and do not allow assumptions about the design to influence the requirement analysis. This is all about the introduction of UML diagram and especially use case diagram. Now in detail all the diagrams structure wise we are going to study in my further videos. So here I am ending my video today. Thank you.